Welcome to The Human Curious. If you're fascinated by the mysteries of the universe, make sure to subscribe and hit the bell icon for more intriguing content. This is gonna blow your mind. Imagine looking up at the vast, dark expanse of the night sky. We see countless stars. We identify familiar planets and our steadfast moon. But what if something else is out there, something truly monumental? Something remarkably familiar yet utterly hidden from our everyday view. Consider a planet. A world very much like our own, faithfully orbiting our sun. This extraordinary idea might sound like pure science fiction, a tale spun for entertainment. Yet, it is a profound question that has ignited human curiosity for many centuries. Could there truly be a celestial twin to Earth, a perfect mirror to our world perpetually concealed by the dazzling brilliance of our star? This thought alone opens up a boundless universe of speculation and sheer wonder, challenging our deepest perceptions of the cosmos and our own unique place within its immense sprawling tapestry. Our sun is an immense and powerful star. Its colossal gravitational pull masterfully holds our entire solar system together, dictating the paths of all its planets. Its brilliant, life-giving light also serves to obscure much of what lies beyond its immediate vicinity and perhaps what lies directly on its other side. Now picture this scenario, an object, possibly a planet, moving in perfect, unwavering synchrony with Earth. It would meticulously share our orbital path, but always, without fail, remain on the opposite side of the sun, a constant, unseen companion. From our vantage point on Earth, we would never see it directly. Such a world, a hypothetical counter-Earth, would exist as a cosmic ghost, its presence only subtly hinted at by faint gravitational nudges on other celestial bodies, or perhaps one distant day, revealed by a dedicated, technologically advanced search mission designed to uncover such secrets. Sometimes intriguing whispers and unconfirmed reports surface in the news, don't they? If you're enjoying the video, don't forget to subscribe, share, and like. The idea of a hidden Earth, a secret twin to our planet, is ancient, dating back to early philosophical inquiry. Greek philosophers, like those from the Pythagorean school, imagined worlds beyond our perception. Philolaus proposed a counter-Earth, or Antichthon, to complete his cosmological model. This idea, rooted in mathematical harmony, persisted through ages, reflecting our desire to explore the unknown. Why does the idea of a counter-Earth, a hidden twin to our planet, captivate our imagination? It speaks to our fascination with twins, mirrors, and doppelgangers. The thought of another us or another Earth is compelling and thought-provoking. It taps into our curiosity about different paths and possibilities. What if a planet shares our orbit but remains hidden by the sun? This isn't just a scientific puzzle, it's a rich storyline with dramatic potential. Imagine a world identical to Earth, hidden by the sun's glare. It would likely have similar seasons and a day-night cycle, but what would its unique history be like? Would it have familiar continents and oceans, or different geology? Would life have emerged, following a similar evolutionary path? The possibilities are endless, creating a tapestry of speculation. What if another Earth exists, and they're watching us? This adds a layer of thrilling, unsettling intrigue. If a counter-Earth civilization is advanced, they face the same challenge of detection. Could they have developed technologies to detect us? Could they already know about us, observing from their hidden vantage point? This transforms the idea into a potential first contact scenario. The fascination with counter-Earth is about what its discovery would mean for humanity. It would alter our understanding of our place in the universe. Are we unique or one of at least two Earth-like worlds in our solar system? Such a discovery would send ripples through every aspect of human society. Ancient wonder about a counter-Earth now meets modern scientific scrutiny. Our sun, a brilliant and massive star, provides a perfect glaring hiding place. Why would a celestial twin be so incredibly elusive if it truly existed out there? Its proposed position, always and forever on the opposite side of the sun from Earth, is key. The challenge for detection is undeniably immense, but science loves a formidable challenge. Our star's dazzling light effectively blinds us to anything lurking directly behind it. Could our hypothetical hidden twin, our counter-Earth, be lurking silently in this L3 region? Section 2. Eyes on the Sky Probes and Telescopes. To unmask a hidden planetary twin, humanity needs a new perspective. Earthbound eyes are limited by the sun's blinding brilliance. Sophisticated spacecraft act as our remote eyes in the sky. Missions like NASA's Stereo offer tantalizing glimpses of hidden regions. Imagine a mission specifically to hunt for a counter-Earth, to answer the profound question, are we truly alone? Section 3. The stability question. A long-term orbit? The universe operates under a strict and elegant set of physical laws. Gravity dictates how planets move and maintain their orbits. The L3 Lagrange point seems like a good hiding spot for a counter-Earth. It is situated directly opposite our planet, shielded from view by the sun. However, L3 is an unstable equilibrium point. The slightest nudge can send it tumbling from its position. Our solar system is a dynamically busy place. Other planets constantly exert their own gravitational influence. Over time, these forces would disrupt an L3 orbit. Perhaps a counter-Earth follows a more complex orbital path. These are fascinating, speculative possibilities. Section 4. Beyond direct sight, indirect clues and modern skepticism. Science, at its core, thrives on verifiable evidence and rigorous testing. As of today, in the early 21st century, there is no direct, confirmed observational evidence supporting the existence of a substantial counter-Earth. Our understanding of celestial mechanics, the physics governing orbits, is remarkably advanced and precise. We meticulously track the movements of all known planets, moons, asteroids, and comets within our solar system. If a massive object, comparable in size and mass to our own Earth, were indeed lurking directly opposite the Sun, we would generally expect to see its gravitational effects on these other celestial bodies. The conspicuous absence of major, unexplained gravitational anomalies in the orbits of nearby planets like Venus and Mars makes many, if not most, scientists deeply skeptical about the counter-Earth hypothesis. The resounding silence from the L3 region is, for now, quite telling. However, the history of science is also filled with instances where questioning prevailing assumptions has led to great breakthroughs. Could it be possible that we have overlooked something subtle in the vast amounts of astronomical data we have collected? Perhaps the long-period comets, those icy visitors arriving from the cold, distant outer reaches of the solar system, behave in slightly strange or unexpected ways as they approach the inner solar system. Their pristine paths might be minutely altered by an unseen gravitational influence emanating from behind the sun, or maybe certain families of asteroids show unexplained clustering or orbital resonances that haven't been fully accounted for. These could potentially be faint, indirect breadcrumbs hinting at a hidden mass. Reanalyzing existing orbital data with the specific counter-Earth hypothesis in mind might reveal previously overlooked patterns. It remains a long shot, but scientific exploration often involves pursuing such unlikely avenues. What if this hypothetical hidden twin isn't quite Earth-sized? Let your imagination consider a smaller world, perhaps something more akin to the size of Mars, or even smaller still. Imagine a counter-moon or a counter-dwarf planet silently sharing our orbit. A less massive celestial body would naturally exert a much weaker gravitational pull on its surroundings. This would make it significantly harder to detect through indirect means, such as the subtle perturbations of other planets' orbits. Its gravitational influence on Venus or Mars would likely be minuscule, easily lost in the noise of other interactions. How could a world, potentially as significant as our own Earth, remain completely hidden from us? The primary reason, of course, is our Sun. This magnificent star acts as an immense, impenetrable curtain. A counter-Earth, if it exists, would be nestled in the L3 Lagrange point. This point lies directly opposite Earth, with the Sun perfectly positioned between us. From our terrestrial vantage point, looking towards L3 means staring straight into the Sun's blinding furnace. This solar glare effectively swamps any faint light that might be reflected from a planet lurking there. It's like trying to spot a firefly hovering just inches from a colossal searchlight. The firefly's tiny glow would be utterly overwhelmed, lost in the brilliance, but the L3 point, as we've learned, is not a perfectly stable gravitational haven. Over eons, the gravitational nudges from other planets like Venus and Jupiter should, in theory, disrupt an object's orbit there. So, for counter-Earth to remain hidden, it must possess some mechanism for stability, or a way to counteract these perturbations. Perhaps its orbit isn't precisely at L3, but rather a more complex halo orbit around it, a delicate dance that keeps it concealed. Or maybe, just maybe, its mass is distributed in such a way that it interacts more subtly with the solar system's gravitational web. Imagine a planet with incredibly dense core but a less substantial outer layer, affecting its gravitational signature in unexpected ways. These are the kinds of cosmic puzzles that stretch our understanding. Could there be other factors contributing to its undetectability beyond just the sun's glare and orbital mechanics? What if counter-Earth possesses natural phenomena that aid its concealment? Perhaps it is shrouded in a perpetual globe-spanning cloud layer, one far thicker and more reflective than Venus's. This could scatter any stray light in ways that make it harder to pinpoint. Or consider the possibility of a unique magnetosphere, one that interacts with the solar wind in a way that masks its planetary signature from our remote sensing instruments. While these ideas venture further into speculation, the universe has surprised us before with its sheer diversity and unexpected phenomena. We must remain open to possibilities that challenge our current assumptions about how planets behave and appear. Ultimately, our inability to detect counter-Earth might also speak to the current limitations of our own technology and search strategies. If this hidden twin, this counter-Earth, truly exists, what kind of world might it be? Sharing our orbit suggests it receives a similar amount of solar energy as Earth. This is a crucial starting point for imagining its environment. The fundamental building blocks for a potentially habitable world, a comparable energy input from its star, would be present. But this doesn't automatically mean it's an exact replica of Earth. Subtle differences in its formation, its geological history, or its atmospheric evolution could lead to a vastly different planetary environment. Imagine an Earth, but with a slightly different tilt to its axis, or a day that is significantly longer or shorter. These small changes can cascade into enormous climatic differences over geological timescales. Let's consider its atmosphere. Would it have one? And if so, what would it be made of? An atmosphere is critical for regulating temperature and protecting any potential surface life from harmful solar radiation. Counter-Earth could possess an atmosphere thick with greenhouse gases, leading to a runaway hothouse effect, like Venus. Or perhaps its atmosphere is thin and tenuous, like Mars, leaving its surface exposed and cold, despite receiving Earth-like levels of sunlight. The composition would be key nitrogen, oxygen, carbon dioxide, methane. The presence or absence of a strong magnetic field, which protects an atmosphere from being stripped away by the solar wind, would also play a pivotal role in its atmospheric destiny. And what about water, the solvent of life as we know it? The habitable zone around a star is often defined by the potential for liquid water to exist on a planet's surface. Since counter-Earth shares our orbit, it lies squarely within our sun's habitable zone. This raises the tantalizing possibility of oceans, lakes, and rivers, but the actual amount of water could vary dramatically. It might be a desert world, with only trace amounts of water ice hidden at its poles. Or it could be a true water world, its surface entirely covered by a global ocean, perhaps teeming with bizarre alien marine life. The balance between land and water, or the complete lack of one, would profoundly shape its climate and any life that might arise. Finally, think about the rhythms of this hidden world. Now, let's take a moment to ponder together. We've explored some fascinating possibilities about this hidden twin, but what do you think? Could there really be a counter-Earth sharing our orbit hidden from our view? How do you imagine its environment, its atmosphere, or even its surface might be? We'd love to hear your thoughts and theories. So take a moment and let us know in the comments below. Your ideas might be as intriguing as the concept itself. Beyond its atmosphere, what might the surface of counter-Earth look like? If it's a rocky world, its geology would sculpt its landscapes. Would it have continents and oceans like our blue and brown marble? Plate tectonics could create mountains, trenches, and land masses. Volcanic activity and earthquakes would shape its surface. Imagine a supercontinent or scattered island chains, a geologically active planet with a molten interior. Volcanoes would dot its surface, creating new land. Eruptions could range from gentle flows to explosive events. Earthquakes would shake its crust. Alternatively, it might be a quieter world like Mars. A more ancient, cratered surface, less prone to upheavals. Impacts from asteroids and comets would leave their mark. Our moon is covered in craters from early bombardment. Earth's impacts are often erased by erosion and tectonics. Would counter-Earth have a similar impact history? Its position might offer unique shielding or exposure to debris. A cratered surface tells a violent past, a smooth one, renewal. Crater density and size provide clues about its age. Counter-Earth could feature entirely unique geological formations. Unique gravity and composition could lead to exotic terrains. Imagine mountains eroded by alien winds or crystallized plains, colossal canyons and towering structures formed by unknown processes. Section 4. Echoes of Life. Inhabitants of the Hidden Twin. If Counter-Earth possesses a similar environment to ours, could it harbor life? The emergence of life on Earth is complex, but the universe is vast. The chemical building blocks of life are common. If conditions are right, life could exist on this hidden twin. It might have begun in ancient oceans or shallow pools. The possibility is enough to send shivers down the spine. What form would this alien life take? Would it resemble life on Earth? Convergent evolution suggests similar solutions. Flight evolved independently in insects, birds, and bats. On Counter-Earth, we might find creatures with fins, legs, or wings. Evolutionary pathways would be unique to that world. Imagine plants using different pigments, painting landscapes in red, purple, or black. Or animals with sensory organs attuned to stimuli we can barely perceive. Could intelligent life have evolved on Counter-Earth? If life arose, complexity and intelligence are possible, what would such beings be like? Would they be humanoid due to similar pressures? Or would their intelligence be in a completely alien form? Their senses, communication, and societies could be profoundly different. The definition of intelligence might need to be expanded. If an intelligent civilization exists, are they aware of us? This is where the hypothesis becomes mind-bending. They face the same challenge in detecting Earth as we do in detecting them, the sun's glare. If their technology is advanced, they might have overcome this obstacle. Could they be studying our world right now? Are they observing our broadcasts, atmospheric changes, and space exploration? The thought that we might not be alone, not just in the universe but in our own solar system, is profound and unsettling. Section 1. The Great Unveiling. First hints of contact. Imagine the quiet hum of a research observatory late one night. Scientists, poring over new data from a specialized probe designed to peek behind the sun, suddenly see it. Not a blurry smudge this time. Not a gravitational wobble easily explained away. Instead, they find definitive, undeniable proof. Counter-Earth is real. Its existence, once a mere philosophical musing, a flight of science fiction fancy, would instantly become the single greatest discovery in human history. The initial reaction within the scientific community would be a mixture of stunned silence, followed by frantic cross-verification. Years, perhaps decades, of quiet, persistent searching would culminate in this singular, electrifying moment of revelation. The weight of this knowledge would be immense, a secret too profound to keep for long. The news, when it finally breaks, would not arrive like a sudden thunderclap. More likely, it would begin as hushed rumors, unconfirmed leaks spreading through online forums and obscure scientific journals. Governments around the world would scramble, attempting to manage the information to prepare their populations for a truth that would irrevocably change everything. But such a monumental discovery could not be contained. Soon official announcements would follow, carefully worded but unambiguous. Counter-Earth exists. Disbelief would be the first global reaction. Then a wave of every conceivable emotion, boundless excitement, profound wonder, and for some, a deep, unsettling fear of the unknown. Our familiar solar system would suddenly feel very different, more crowded, more mysterious. The immediate scientific imperative would shift from mere detection to intense scrutiny. What are the first signs of intelligence, if any? Astronomers would train every available instrument, every sensor, towards the newly confirmed world, desperately trying to glean more information. Are there patterns of light on its night side indicative of cities? Does its atmosphere show chemical signatures of industrial activity, or perhaps even biological processes on a massive scale? Radio telescopes would listen with an unprecedented focus, searching for any intentional signals, any leakage of artificial communication. The search for extraterrestrial intelligence, SETI, would no longer be a hopeful gaze into the distant stars. It would be an urgent listening session with our closest hidden neighbor. Even before any direct communication is established, or even before we know if its inhabitants are microbes or mathematicians, the philosophical impact would be staggering. Humanity would collectively awaken to the knowledge that we are not alone, not even in our own orbital backyard. Our sun, that familiar celestial body, would now be seen as a shared star, a barrier between two worlds born of the same cosmic dust. The night sky itself would feel different, imbued with a new presence. This realization alone would force a profound reevaluation of our place in the universe, prompting a global conversation about what it means to be human and what it means to share our cosmic home. The long age of human solitude, real or perceived, would be over. Section 2. Bridging the Solar Divide. The Challenge of Communication. Discovering counter-Earth is monumental. Communicating with potential inhabitants presents colossal challenges. The sun remains the primary obstacle. Radio waves would be distorted or absorbed by the sun's radiation. The light travel time means minutes of delay, making real-time conversation impossible. It would be like shouting across a raging bonfire. What kind of message would humanity send first? The composition of that first hello would be one of the most carefully considered messages in human history. The challenge of bridging the solar divide could push our scientific capabilities to unprecedented heights. Section 3. Reflections in a Cosmic Mirror Sociological Upheaval. The confirmation of a counter-Earth would send profound shockwaves through human society. Consider the impact on our diverse global cultures and myriad religious beliefs. How would belief systems adapt to another Earth sharing our sun? Some might see it as a divine affirmation, others as a challenge. The discovery could act as a catalyst for global unity or deeper division. It would be a true test of human maturity on a global scale. Would nations pool resources or compete for cosmic standing? The reflection in that cosmic mirror would force us to see ourselves in a new light. Section 4. Philosophical Quandaries and the Human Condition. The discovery of a counter-Earth would force us to redefine humanity's perceived uniqueness. For millennia, we have seen ourselves as special in a vast, silent cosmos. Learning that another Earth-like world shares our orbit would shatter this illusion. It would suggest that the conditions for life are not as rare as we believed. This wouldn't diminish humanity but recontextualize our existence. Our cosmic loneliness would be replaced by cosmic companionship or rivalry. This discovery would fuel the debate about the Great Filter. What if their civilization is long dead, a testament to a filter they failed to overcome, or if they are far less advanced, struggling with challenges we have faced? Their state would provide crucial data in understanding our future trajectory. The question of ethics would loom incredibly large. If we develop the capability to observe them in detail, should we? Is it morally right to study another civilization without their knowledge or consent? This is the prime directive dilemma, familiar from science fiction, suddenly made very real. What if we discover they are on the brink of self-destruction or facing a natural catastrophe? Would we have a moral obligation to intervene, assuming we even could? And what if their societal values are radically different from our own? The ethical tightrope we would have to walk would be fraught with unprecedented complexities. Ultimately, the discovery of an inhabited counter-Earth would force humanity to confront its deepest hopes and fears. Are they likely to be benevolent explorers, eager for peaceful exchange and mutual understanding? Or could they perceive us as a threat, or perhaps merely as insignificant? The range of possibilities is vast, from utopian dreams of shared knowledge and cosmic brotherhood to dystopian nightmares of conflict and subjugation. This single discovery would act as a mirror, reflecting not just their nature, but our own. It would compel us to look inward, to examine our own tendencies towards peace or aggression, curiosity or fear, as we prepare to potentially face our cosmic twin across the fiery heart of our shared sun. It would compel us to look inward, to examine our own tendencies towards peace or aggression, curiosity or fear, as we prepare to potentially face our cosmic twin across the fiery heart of our shared sun. It would compel us to look inward, to examine our own tendencies towards peace or aggression, curiosity or fear, as we prepare to potentially face our cosmic twin across the fiery heart of our shared sun. The idea of a counter-Earth, a hidden twin to our world, holds an undeniable fascination. This captivating concept has journeyed with us through millennia. It first sparked in the minds of ancient Greek philosophers. It continues to ignite our modern imagination today. Why does this particular what-if scenario resonate so deeply within us? Perhaps it speaks to a fundamental human desire to find reflections of ourselves in the vastness of space. It could be our innate curiosity about the unknown, the tantalizing possibility that something familiar yet entirely new lies just beyond our current perception. This enduring allure keeps the question alive. a cosmic question mark hanging over our understanding of our own solar system and our place within its grand design. Science, with its rigorous methods and demand for evidence, presents significant challenges to the simple existence of such a hidden world. We have explored the difficulties of orbital stability at the L3 Lagrange point. We have noted the current lack of direct observational proof, despite our increasingly sophisticated instruments. Yet the very nature of scientific endeavor is to push against the boundaries of what we think is possible. The absence of evidence is not always evidence of absence, especially when searching in the challenging glare of our sun. The allure persists precisely because it represents a frontier of knowledge, a place where certainty gives way to the thrilling potential for discovery, however remote that possibility might seem to our current understanding. Even if a counter-Earth remains firmly in the realm of speculation, the very act of considering its existence serves a vital purpose. It actively fuels our collective imagination, inspiring artists, writers, and thinkers to dream beyond the confines of the known. This thought experiment stretches our cosmic horizons, prompting us to ask deeper questions about planetary formation, the conditions for life, and the sheer diversity of worlds the universe might contain. The idea itself becomes a catalyst for creativity and for contemplation. It encourages us to look up at the sky not just with our eyes, but with our minds wide open to the extraordinary possibilities that may lie hidden from our immediate view. Furthermore, the enduring question of a hidden twin subtly pushes our scientific capabilities forward. The challenge of detecting such an object, if it were there, forces us to refine our astronomical techniques. It encourages the development of new technologies and innovative observational strategies. In searching for something so elusive, we invariably learn more about our sun, about the subtle gravitational dances within our solar system, and about the limitations of our current methods. Thus, the quest for a counter-Earth, whether it ultimately yields a hidden planet or not, contributes valuable knowledge to our broader understanding of the cosmos. The journey of inquiry itself is a source of profound discovery. The idea of a counter-Earth, a hidden twin to our world, holds an undeniable fascination. This captivating concept has journeyed with us through millennia. It first sparked in the minds of ancient Greek philosophers. It continues to ignite our modern imagination today. Why does this particular what-if scenario resonate so deeply within us? Perhaps it speaks to a fundamental human desire to find reflections of ourselves in the vastness of space. It could be our innate curiosity about the unknown, the tantalizing possibility that something familiar yet entirely new lies just beyond our current perception. This enduring allure keeps the question alive, a cosmic question mark hanging over our understanding of our own solar system and our place within its grand design. Imagine, for just a moment, that the search yields a positive result. Imagine that scientists announce to the world, counter-Earth is real. The discovery would transform humanity's understanding of its place in the cosmos. We would no longer be the sole Earth-like planet in our orbit around the sun. The psychological shift would be monumental. Our perceived uniqueness would give way to a new reality of cosmic companionship. This would force a fundamental re-evaluation of what it means to be human. The confirmation of a counter-Earth would galvanize human ambition for space exploration on an unprecedented scale. It would become the new moonshot, the next great horizon for scientific inquiry and technological development. Governments and private organizations would redirect significant resources towards understanding this newfound neighbor. The drive to learn more, to see it up close, would become a powerful unifying global endeavor. New missions would be designed, new telescopes built, inspiring a new generation to look towards the stars. Our journey through the concept of a counter-Earth brings us full circle, from ancient philosophers to modern astrophysics. The idea, whether true or not, enriches our understanding and stretches the boundaries of our scientific inquiry. Even if counter-Earth remains science fiction, contemplating its existence refines our models and sharpens our scientific tools. The human quest for understanding is a continuous journey, driven by our innate desire to explore and comprehend the cosmos. The universe holds countless secrets, and our desire to uncover them is an unquenchable fire. Thanks for watching. If you enjoyed this video, please subscribe, share, and leave a comment with your thoughts.